In this video, I'll show you how to run any Hugging Face model locally into your system. And to achieve this, we will first download and save the model in the local system, and after that, we will use that downloaded model for our inferencing. So in this particular video, we will download and run this Llama 3.2 model, which is provided by Meta, but you can download any model in the same way. The steps are going to be the same. If you observe here that this particular model has 1 billion parameters, so this is comparatively lightweight, and that's why I have selected this particular model for the video. So what's the real benefit of downloading these models before actually running them? So first, these models are usually quite large, often in gigabytes. For example, if I show you, this model itself is around 2.5 GB, and this is when we have selected comparatively the smaller model. Now if we load these models dynamically every time we use them, it will download all the files of the model on the fly each time, which is not an efficient way unless we want to use them only once. Now instead, if we download and save the model in our local system, we only need to do that once. Then with the model saved locally, we can load it directly from the saved path and run it easily each time without re-downloading. Now first of all, we will go to the location where our project is present, or just go to the location where you want to create the virtual environment. For me, I want to create the virtual environment in the downloads folder. So I will open the terminal first. So command and space, then type terminal. Let's maximize this. And here I will go to the downloads. So I'll type cd, then downloads. Now to create the virtual environment, I will type python 3 space -m venv space and the name of the virtual environment. So let's keep it hf_practicals. So this command is for Mac system, but if you are using Windows, then you would see the command on screen. So let's hit enter. And once the command is executed, we will have one folder created with this name hf_practicals inside the downloads folder. So let me show you in the downloads folder. So here we have this folder. Now in order to activate this environment, we will source the activate file which is present inside this folder itself. So if I open this folder, then go to bin. So here we have this activate file which we need to source. So I'll again go to the terminal, and here I will run source space, then I'll give the path of the activate file hfpracticals, then bin, then activate. Again, this command is for Mac, and for Windows you can see the command on screen. Now we will hit enter. Now you would see this hf_practicals within these brackets, which means this particular environment is currently activated. Now in this activated environment, we will install Jupyter Notebook. So we will type pip3 space install space Jupyter. Now again hit enter. The installation is taking place and it might take a couple of seconds here. The installation is finished now. Let me clear the terminal once. Now first of all, we will go inside the hf_practicals folder. Otherwise all the ipynb files will get created inside the current folder, this downloads folder, instead of our project folder. So I'll say cd, then hf_practicals. Now before launching the Jupyter server, we will install couple of libraries in this activated environment because we will require those to run our model. The first one is PyTorch. So we will type pip install, then torch. Now hit enter. It is installed successfully. Now we will install transformers library. So again we will type pip install, then transformers. Okay, so this is also installed. Now let me clear the terminal once. And to launch the Jupyter server, we will type Jupyter space notebook. So this is launched in the new tab. Now here we will create a fresh notebook, and for that we will click on this new here and select this Python 3 IPY kernel. So our notebook is created in the new tab. Now in this notebook we will write our code to download and run Llama 3.2 model from Hugging Face. Now before that, let's give it some name. So let's say run hf model. So first of all, we will import the torch package. So we will write import torch. Let's run this. Now we will import auto model for causal LM and auto tokenizer from the transformers library. So we will write from transformers Then import auto model for causal LM and auto tokenizer. Let's run this as well. Now we will quickly create the Hugging Face token because this will be required next. So let's open the Hugging Face website. And once we are logged in, we will click on this profile icon, then click on settings, then access tokens here, and here we will click on this create new token. From here we will select the token type. I have already explained about these in detail in the token creation video. So for now I will go ahead with the read type. Now here we will give the token name. So let's say this is run_hf_model. Finally click on this create token. Here we will copy this token and keep it in a safe place because we won't be able to see it again once we close this pop-up window. So once we have copied this, click on done here. Now again we will come to the notebook, and here to keep it simple I will directly assign this token to a variable. So I will say access_token equals to the copy token. But if you want, you can keep this token in the environment file and then you can use this as an environment variable, and this is the code for that. So let's run this as well. Okay, so this should be in the string format, so let's keep it like this. Now we will finally write the code to download the model. So first of all we will define a variable. So let's give it model name, and now here we will write the name of the model which we want to download. Now you might ask from where we will get this name. So for this we will go to the Hugging Face and open the desired model which you want to download. Like for this Llama 3.2 model, this is the identifier which we copy here. So let's copy this and paste it here. Now it's time to load the model and tokenizer into our environment, and after that we will save both of them, the tokenizer and the model, into our local system. So to load the tokenizer we will write tokenizer equals to auto tokenizer dot from pre-trained this model name, and the token equals to access token, which is this one. Here we need to pass this access token parameter so that the Hugging Face can authenticate us and it can know which user is trying to download the model. Now similarly, to load the model we will write model equals to auto model for causal LM dot from pre-trained model name and token. Auto model for causal LM dot from pre-trained model name and token. Let's run these cell as well. So let's run this first, then this one. So this is completed now, and for me it took quite considerable time, so please be patient here. Now we will save these two things on our local. So we will write tokenizer dot save pre-trained, and here in this method we will pass the path wherever we want to save this in our system. So let's say we want to create one tokenizers folder inside the current folder, and inside that we want to save this tokenizer. So we will write tokenizers, then inside that we will create one more folder with the name of the model name. So it will first create this tokenizers folder, and inside that it will create one more folder with the model name, which is this meta llama 3.2 1 billion, and inside this folder it will save the tokenizer. Now similarly we will save the model as well. So we will write model.save pre-trained, and again we will give the path. So let's copy this from here and let's change this to models. So this time it will create the models folder, and inside that it will create one more folder with the model name. So let's run this cell. So it is completed now, and if I show you in the finder, so I'll go to the finder again, and here if I show you under this HF practicals, let me collapse this, and here if you see this models folder is created and this tokenizers folder is created, and inside this models we have this meta llama folder, and inside this llama 3.2 1 billion mod folder, and inside this all the files are there. Similarly The same case is for the tokenizers. So here also MetaLlama, then Llama 3.2 1 billion, and the files are there. Now we will go back to the notebook. Now once we have downloaded and saved the model and tokenizer, we will load these so that we can use them for our inferencing. So first we will load the tokenizer, and for that we will write tokenizer equals to auto tokenizer from pre-trained, and here we will pass the path where our tokenizer is present. So we will pass the same path. So this was our path, so let's copy this from here. And now similarly we will load the model as well. And now again we will give the path. Let's run this as well. Okay, so now we will give our prompts to this loaded model. So let's define the prompt first. So we will write prompt equals to, then let's say what is the capital of India. So this is our prompt. Let's run this cell. Now before passing this prompt to our model, we will have to tokenize this using the tokenizer, and we will use the tokenizer which is corresponding to our model. So we will write tokenizer, and in this we will pass the prompt, then return tensors. So here we will use the same tokenizer which we have loaded above. Now let's assign this to a variable. Now here this second parameter is to tell the tokenizer about the format, like in which format we want the encoded data. And here this PT stands for PyTorch. So we want the output in the form of PyTorch tensors. So the tokenizer will convert the tokenized text into the PyTorch compatible tensors. Now let's run this cell as well. And now we will print this embedding. So let's run this. So here we have the tensors for the prompt and the attention mask as well. Now we will pass this embedding to our loaded model. So we will write response equals to model.generate this prompt.embeddings. So let's run this. So here it is giving some warning which we can ignore, because this is just saying that we have not provided this max new tokens parameter. So it took the default value which is 20. Now let's print the response. Let's wait for a while here. So we have got the response here, but it took a little while for me, around 2 to 3 minutes. Again, this is the encoded response. Let's decode this using the same tokenizer. So we will type print, then tokenizer. We will use the same tokenizer here, and we will say tokenizer.decode, and we will pass this response. So inside this response we will pass the response of 0. We need the response of 0 here. So let's run this as well. So this is the response which we have got from this Llama 3.2 model. So according to model we will get the different response here. Now let's say we want to generate a bigger response which is more than 20 tokens. So we will pass the max new tokens parameter while generating the response. So let's do the changes in this line itself. So here we will pass this max new tokens parameter, and let's keep this 100. And before this let's change the prompt as well. So let's say the prompt is now write a poem on machine learning. Now let's run this. Okay, so this is run. Let's run this as well. This is also executed. Let's print this as well. So this is also executed. Let's run this now. This time it might take more time because it has to generate a bigger response. So it got executed, but I had to reduce the max new token size from 100 to 30 because it was taking way too long time to execute this cell. But I guess you got the idea. Let's now run this cell as well, and let's print the response as well. So we have got the response here, which is longer than the previous one because we have increased the max new token size here. Now if you want to learn more about Ollama and Hugging Face, then do check out the Hugging Face playlist on the channel. I am sure you will learn a lot of things from those videos, and you can also subscribe the channel for more such videos.